All right, what's up everybody? Tuesday's video lesson here, EOG Geometry Review Day 2. We'll be doing a little bit of surface area and volume today. Again, warm-up notes and then the problematic at the end. Warm-up, number 1, breaking it apart, making the problem easier to solve. We have 2 times n minus 5, all being divided by 4 is the same as 27. So the first thing I did was broke it apart. We have 2 over 4 times n. There's only one symbol to keep, so minus 5 over 4 equals 27. First thing I need to do, get rid of the minus 5 over 4, so I added 5 over 4 off to the side. We drop down to 2/4 n. Now we're going to say 27 plus 5 over 4 is 28 and 1/4. 2/4 times n, so we're going to divide each side by 2/4. 28 and 1/4 divided by 2/4 gives us a solid answer of 56 and 1/2. Number 2. Mr. Sanchez bought 2 magazines for $9.95 each and 1 book for $14.95. We got a 6% sales tax and we want the total cost at the end. First thing we had to do was scan our items, figure out how much he bought. 2 notebooks and 1 book. That means he spent $34.85 on those 3 materials. He took that price. He was charged 6% of that price, meaning he was charged $2.01 for the sales tax. Tax is an additional fee, so the original price plus the tax, $36.94. Answer choice is D for number 2. Number 3, moving along here. Circle B has a circumference of 252, and we want to know what's the approximate radius. Well, the first thing I kind of thought about was, well, I need a radius or a diameter, but they didn't give me that. So the next best thing is figure out, well, they did give me circumference. I know the circumference is 252, and I know that pi times the diameter would tell me that circumference. So we're going to find out the diameter by dividing each side by pi. 252 divided by pi, that's the diameter. It means my diameter is roughly about 80.2. But this question, we have to be careful because that's one of those trap answers. We're looking for the radius, so I divided my diameter by 2, and I find out the radius, is approximately 40.1. Again, your decimals could be off by a little bit. And last one, number 4, determine the surface area of the figure below. Again, first thing we want to do is break this shape apart. Today we're dealing with a triangular prism. It has 2 triangles in the front and the back. The sides that come up and touch at the top are rectangles, and it's also sitting on a base of a rectangle. So, first thing I did was broke it apart. I know that there's a front and a back triangle. I also know that there's a left side, right side, and a bottom rectangle. From there, well, how do I find the base and the height? I know 1/2 base times height would give me my area. So again, first thing other than that, I listed my 2 formulas I need. So I know that I need area is length times width, and area is 1/2 base times height. So these are my 2 formulas because I have triangles and rectangles. First thing, well, how do I locate the base and the height? Remember, it's where a right angle forms inside the triangle. Right there, they're telling us that the height is 3 and the base is 5. So I know that 1/2 times 3 times 5 would give me 7.5. And I know that these triangles are the same because it's a triangular prism, which means that the 2 sides that are congruent name its shape. Since it's a triangular prism, the triangles are congruent, they're the same. So once I found one, I went ahead and listed it twice. From there, I know that the left side, okay, the one that's facing me, if I code it in and I trace it, I have a 6 and a 12 side, so that's 6 times 12, which is 72. The back side, a little tougher to see, but again, we're going to think about what's true in geometry. These 2 lines right here are parallel, so I know that they're both 12. Off to the side, remember, this was the height of the triangle. The only other dimension they give us is that 6. So that 6 must also be not only the side of the triangle, but also the width or the length. So again, I have another 12 by 6. So the right side is 72, and when I trace the bottom, I have a 12 times 5. So the bottom's actually a little bit different. It's 12 times 5, which is 60. Okay? And again, all I did was trace that with my pencil. 12 by 5, 6 by 12. And again, that back side, well, I know that if the left side's that and the back side, that right side doesn't have anything, then they're congruent, they're the same. Last step, once I have all my areas, you add them together, and you would have found out that the total surface area was 219 units squared. Okay, we're going to be focusing a little bit more on this today, but before we get there, let's do a little daily dose of algebra. So first thing I'd like you to do is solve these 2 problems that are on that sheet. When you're done, try to pick the correct solution set. Unpause the video when you want to check. All right, here we go. First one, -3 times x minus 5 is greater than 10. Well, the first thing, always identify my coefficient. Do I have a negative coefficient? Yes. That means that symbol's going to flip. So at the end, I know that I'm going to have x is not greater than. X is going to flip, so x is less than a number. Well, first thing I did to mathematically solve it, I had +5 on both sides. 10 plus 5 is 15. I have -3 times x is greater than 15. This step right here is why I'm flipping my symbol, because I'm dividing by a negative coefficient. Whatever I do to one side, I do to the other. So x, the symbol flips from greater than to less than. 15 divided by -3 is -5. So x is less than -5. That's only part of the solution though, okay? Now I gotta look. I have 3 choices. Remember, all the numbers need to be true. So I'm gonna read them out loud and then we're just gonna kind of go through and either put a check mark or cross out the ones that are true and false. -5 is less than -5. No, right there I'm eliminating that entire answer choice. It does not matter if the other choices are correct. As soon as you find one number that makes your inequality invalid or untrue, it's not the answer. 4 is less than 5. No. 0 is less than -5. No. -1 is less than -5. No. -5 or -2. So in this problem, 3 real numbers. This one was the closest, but it should have started at -6, then -11, then -15.5, okay? Or if we put a line underneath of that, then yes, that would have been true. So on that one, just got to be a little careful. We had a little mistake with the answer choices. But we should have been looking for numbers that were all less than, all to the left of -5. Second one, let's try this one out. Again, I put a box around my variable and its coefficient. Well, even though there's no number there, I know that's 1x, but it's -1x because of that minus sign. So, again, first thing I need to do is solve it. I have +7, that means I subtract 7. Drop down my -1 times x, drop down my symbol because I haven't divided by anything yet. 3 minus 7 is -4. But again, I can't leave this alone. I can't have a negative variable. So again, that's -1x. I can divide by -1 because that -1x divided by -1 is +1x. That's what I'm looking for. And then -4 divided by -1 does indeed give me +4. But I flipped my sign because right here I divided by a negative. So again, now I have x is greater than 4. Well, let's take a look. Is -4 greater than +4? No. Is +4.5 greater than 4? Yes. Is 6 greater than 4? Yes. Is 7 greater than 4? Yes. We have 3 good answers. Yes, they're true. Just to check the bottom one, is -2 less than 4? No. Is 3 less than? No. 19, yes. But again, as soon as you get one no, we can just throw out the entire solution set. So again, it's really important that you know how to solve them and also make a solution set and therefore a graph. All right, so again, know your formulas, make sure you get them written down. Again, I would start thinking about what else can I add to that cheat sheet at the end of the year when I get my scrap paper, maybe a number line, maybe some angle stuff. You just gotta think, what do I struggle on and what can I use before the test starts to help me out? All right, volume. First thing we're gonna take care of today. The amount of space on the inside of a 3-dimensional prism. So we're trying to see how much space is in the middle of this triangular prism. Couple of things. We need to find the area of the base, identify the height of the prism, and then we multiply those things together. Again, I have a triangular prism. The generic volume formula is volume is the same as the area of the base times the height of the prism. But big B could mean a bunch of different things. It could mean length times width for squares and rectangles, or in a triangular prism, it means 1/2 base times height or base times height divided by 2. But I cannot forget to multiply it times how tall or the height of the entire prism. So, again, I started with that generic formula. Then I thought to myself, well, what type of prism did they give me here? They gave me a triangular prism, meaning that big B, that area of the base, really means this right here that I'm going to put in parentheses. It means 1/2 times the base of the triangle times the height of the triangle. But again, I can't forget about multiplying it times how tall the entire prism is. So, again, how can I find the base and the height? Well, I look at my triangle, I try to locate a right angle. Right there's a right angle. So the base of the triangle is 6, the height of the triangle is 4. So the first thing we had to do was 1/2 times 6 times 4. Now, as you can see, it says times 12 up there. But if you ever get confused, remember, you're going to stand it up, just like when you go to the doctor's office. You stand up nice, straight, and tall. Well, this triangular prism is actually laying on its bottom or on its back. So what I'm going to do is just take the picture and I'm going to rotate it so that it's standing up nice, straight, and tall on its base, its triangle. And then I can clearly see, hey, that 12 is how tall the entire structure is. Once I write out my formula and I plug in my numbers that I need, 1/2, base of the triangle, height of the prism, I put that in a calculator and I have the answer of, I erased the millimeter squared part, but it's 144 millimeters cubed. Millimeters cubed because we're doing millimeter times millimeter times millimeter, millimeter to the third. And that's our answer. So again, identify the base, identify the area of the base, multiply it times the height of the prism. This one, pause the video, see if you can try this one on your own. When you're ready, unpause the video and I'll go over it. All right, here we go. Well, again, we have a triangular prism. Well, I got to think what's true about triangular prisms. Well, all volume problems, area of the base times the height of the prism. Again, I know that this is a triangular prism. So 1/2 times the base of the triangle times the height of the triangle times the height or the height of the entire prism. Again, I'll locate my right angle. Right here in this problem, that is my right angle. Here's the base of my triangle, the height of my triangle. 1/2 times 8 times 6. And again, this 12 is really a distractor because if I stand my triangle or my rectangle or my triangular prism here on its base, again, we have the base and the height of the triangle, but we clearly see how tall is the entire structure. It's 10. So again, this 12, if this was surface area, that 12 is extremely important. But in a volume problem, I have 3 variables: base of the triangle, height of the prism. And I only need 3 out of those 4 numbers. Once I have it set up, I put it in a calculator, I press enter, and I would find out that the answer was 240 units cubed, or cubic units. Moving on, we'll get into a little surface area. This, our strategy, remember the total area of the outside of a 3-dimensional figure, and we're going to find the area of each individual section, and then we're going to add them together. Well, the first thing I need to do in this problem is break it apart. All rectangular prisms, you just think about them as a shoebox. They have a top and a bottom, a left side and a right side, a front and a back. So that's exactly what I did. I just took it and broke it apart. That is the first thing I'm going to do in all surface area problems, is just take the figure, break it apart. I labeled them front, back, left side, right side, top, bottom. Now, easiest strategy for this is to trace the prism and either whatever side you're picking. So I'm going to start with the front. If I trace the front, I go by 10, but I don't go by another number. So I got to think, is there a parallel side? The top is the same as the bottom, but they're both 10. It's not a square, it's definitely a rectangle. The left side, the right side also are parallel with this side that measures 8. So again, I'm going to know that this is a 10 times 8. 10 times 8 is 80, and I know that the front and the back are exactly the same. Sometimes you have to trace the back too. That's another good strategy. See, I passed just 8 on the back and just 10 on the front. And again, we know the front and the back are the same, so we know the length is 10, the width is 8. From there, I'm going to move on to one of my sides. Let me erase what I have. I'm going to pick the left side. Well, if I trace this left side, there's nothing there. That's not going to help me, so I'm going to try the right side, see if that helps. When I trace the right side, I go by 7 and 8. So the left side and the right side must be the same. They both are 8 times 7, which is 56. And the last side I have to do is the top and the bottom. Again, if I were to trace the top, there's no dimensions up there. There's no lengths and widths. That's not really going to help me. If I look at the bottom and I trace with my pen, I go by 10 and 70, or 10 and 7 rather. So 10 times 7 is 70, and I know that the top and the bottom are the exact same. Once I have all 6, the only thing left to do is to take my calculator and add them together, and we would get 80 plus 80 plus 56 plus 56 plus 70 plus 70, 412 units squared. All right, again, just break the shapes apart, find each individual length and width. Once you have all 6 sides of a rectangle prism, 5 sides of a triangular prism, you have the answer. Just add the areas together. Okay, last one. I put a little hint up here. Here's your 2 formulas you're going to need. 1/2 base times height, or base times height divided by 2. And then area of a rectangle or square, length times width. So take a second, unpause the video. You should end up using only 3 of these dimensions. You got to think to yourself, you should end up using all 4 dimensions in this, since this is a surface area and not a volume problem. So for every dimension or every side, you should end up using 3, 4, 6, and 4 all together. So I'll pause the video, see what happens. When you're ready, unpause the video. Here we go. Again, first thing I want to do is break it apart. The front and the back are both triangles. I have a front triangle and a back triangle. I know they're the same because they're congruent, they're opposites, they're the same. I have a left side and a right side. They come together, touch at the top. And then on a triangular prism, I have 3 sides of the triangle, so I have 3 rectangles coming off, the left, the right, and the bottom. Let's deal with our triangles first. Again, not forgetting my formula, 1/2 base times height. So again, I'm looking for a right angle. Right there's my right angle. 4 is the base, 3 is the height, so it must be 1/2 times 3 times 4, which gives me 6. So 1/2, 3 times 4 is 6. I know that the front and the back are the same, so again, all I did was just copy that 6 down. Next one, let's look at the left. Now I can never assume that anything in a triangular prism is the same. The only thing I know is that the opposite congruent sides are the same. There are no other opposites. The left and the right really aren't opposites because opposites are parallel. They would never touch. And clearly the left and the right touch at the top. So again, I can't assume that they're the same, but sometimes they are. So in this problem, again, the left side, well, there's nothing really there, so that's not going to help me. So that means that the left and the right are going to be the same because they didn't give me any dimensions on the left. So again, I'm going to trace the right. Let me get rid of what I did already. Now, as I trace, I go by 6 and I go by 4. So right there, I know that the left side and the right side are both going to be 6 times 4s because again, the left side, there are no dimensions. So I got to think, is there any other congruent side or are there other dimensions that are opposite to it? So I have 2 sides that are 24. Again, I'm going to take my pen and pencil and I'm going to trace the bottom. Here, I go by 6 and I go by 4. So this is actually an equilateral triangle. Equilateral triangles, all the rectangles are going to be the same. So I do have 3 sides that are 6 times 4 or 24. I have my 2 triangles that are 1/2 times 3 times 4. And then at the end, last step, once I have all my dimensions, I'm going to do 24 plus 24 plus 24 plus 6 plus 6. So again, I have 24 plus 24 plus 24 plus 6 plus 6. Here we have 48 plus 24 plus 6 plus 6. We have 72 plus 12. We have 84 units squared. Okay? That wraps up today's lesson. From there, you have your bit.ly. When you're done, raise your hand. You should have your notes, your warm-up, and your problematic bit.ly finished today.